On March 14, 1879, in the German city of Ulm, a child was born with a deformed skull, and doctors were not sure he would survive. His mother cried. His father, a small-time feather merchant, stood silently by the door. No one in that room suspected that in 26 years, this boy would rewrite the laws of the universe, and 60 years later, with a single letter, help trigger the creation of the most destructive weapon in history. His name was Albert Einstein, and his life resembles a novel no science fiction writer would dare invent. Little Albert did not speak until the age of 3, and until 7 he repeated every sentence silently to himself before saying it aloud. Teachers at the Munich gymnasium considered him slow because he refused to memorize material and constantly argued with instructors. The only subject that fascinated him was mathematics, and the only hobby that stayed with him for life was the violin. He played every day and carried the instrument everywhere, claiming that music helped him think better than any textbook. Whenever a difficult problem resisted solution, Einstein would set aside his papers, pick up the bow, and play Wolfgang Amadeus Mozart until the answer came by itself. Until the age of 12, Albert was deeply religious because the Catholic school in Munich had instilled sincere faith in him. But then he began reading popular science books, and his faith collapsed within months. Later, he would say that at that moment he understood something fundamental. The only authority worthy of trust is a verifiable fact, not tradition. When Albert was 5, his father showed him an ordinary compass, and that moment changed everything. The needle stubbornly pointed north, even though no visible force pushed it. The boy realized something many adults never understand. Behind the visible world lies something deep and invisible that governs everything. That compass became for Einstein what the apple was for Isaac Newton. He never finished gymnasium because he ran away to join his parents in Italy. Without a diploma, he tried entering the Zurich Polytechnic. He passed mathematics and physics brilliantly but failed French, chemistry, and biology. He was given a second chance and sent for a year to a school in the small Swiss town of Aarau. There, in the quiet of the countryside, a question emerged in the mind of the 16-year-old that would explode physics 10 years later. What would a person see if they ran alongside a beam of light at the same speed? It was such a strange question that no professor would waste time on it. Professors generally did not want to deal with Einstein because his independence irritated them. After graduating in 1900, the young physicist could not find work, not even a position as a school teacher. For 2 years, he practically starved, sometimes going days without food, and developed liver disease that troubled him for the rest of his life. Imagine the future author of the most famous formula in history searching his pockets for coins to buy bread. Finally, in 1902, he got a job as a third-class examiner at the Bern Patent Office. From that office, from the desk of a clerk reviewing invention applications, came a revolution unlike anything physics had seen since Newton. Physicists call 1905 by a Latin phrase meaning the year of miracles. In just a few months, the 26-year-old patent clerk published 4 papers, each of which alone could have secured him a place in scientific history. The first explained the photoelectric effect and laid the foundation for quantum mechanics. It later earned him the Nobel Prize. The second proved the reality of atoms by explaining Brownian motion. The third introduced the special theory of relativity, overturning humanity's understanding of space and time. And the fourth contained the formula every schoolchild now knows, E_mc². If you are around 26 years old, think about this for a moment. At that age, an unknown Swiss clerk rewrote the foundations on which science had stood for 200 years. No university wanted him. No professor considered him a serious researcher. The most astonishing thing about Einstein's discoveries is that they were made not in laboratories, but in his mind. He called them thought experiments. Einstein did not observe atoms through microscopes or accelerate particles in giant machines. None of that existed in 1905. He sat down, closed his eyes, and imagined scenarios. What happens if an elevator falls endlessly through empty space? What happens to clocks aboard a train approaching the speed of light? From those imagined scenes emerged equations later confirmed to astonishing precision. Special relativity claimed things so strange they seemed to defy common sense. Time passes differently for people moving at different speeds. This is not philosophy. It is measurable physical reality. If you traveled near the speed of light and returned after 1 year by your own clock, decades would have passed on Earth. Your friends would be old while you remained young. Modern experiments with atomic clocks on airplanes confirmed this effect with extraordinary accuracy, but special relativity was only the beginning. 10 years later, Einstein completed what is still considered one of humanity's greatest intellectual achievements. The General Theory of Relativity, published in 1915, it proposed something almost unimaginable. Gravity is not really a force at all. Massive objects such as stars and planets bend space and time around themselves. Other bodies simply move along these curves, like a marble rolling across a stretched sheet dented by a heavy ball. Earth does not pull us downward. It curves space-time, and we follow that curve. When Einstein presented this theory, most physicists did not understand it. The mathematics was so difficult that even Einstein himself spent years mastering it. The first great confirmation came in 1919. British astronomer Arthur Eddington measured the bending of starlight during a solar eclipse. The light curved exactly as Einstein's theory predicted. Newspapers worldwide announced that a man had proven Newton wrong. Overnight, Einstein became the most famous scientist on Earth. His face appeared on magazine covers. Heads of state invited him to receptions. Crowds attended his lectures without understanding a word, simply to see a living genius. Later, Time named him Person of the Century. In the 1920s, he traveled widely to Japan, China, India, and Palestine, and everywhere he was treated like a rock star before rock music even existed. He received the Nobel Prize in 1922, not for relativity, which the committee considered too revolutionary, but for explaining the photoelectric effect. Fame did not change him. He still wore no socks, kept the same leather jacket for years, and cut his hair only when he remembered. The famous photograph of him sticking out his tongue was his response to photographers demanding a smile on his 72nd birthday. But behind the image of the funny, disheveled professor was tragedy. His first daughter, Liesel, was born before marriage in 1902, and her fate remains unknown. Historians believe she either died of scarlet fever or was given up for adoption. His younger son, Eduard, suffered from schizophrenia and spent most of his life in psychiatric clinics in Switzerland. Einstein sent money for his care, but never saw him again after emigrating to America. This was a man who unraveled the structure of the universe, but could not save his own child. In 1933, when the Nazis came to power in Germany, Einstein was in America and decided never to return. He publicly renounced German citizenship. The Nazis placed a bounty on his head and burned his books in public squares alongside other un-German literature. German propaganda even published a pamphlet titled 100 Authors Against Einstein, attempting to discredit relativity. Einstein reportedly replied, "If I were wrong, one author would have been enough." In Princeton, he lived modestly, walked to work, and often spoke with children along the road, explaining the universe in simple language. It was there, in August 1939, that Einstein signed the letter that changed history. On August 2, he signed a letter to President Franklin D. Roosevelt warning that Nazi Germany might develop an unimaginably destructive bomb based on uranium chain reactions. The text was written by Hungarian physicist Leo Szilard, who needed the world's most respected scientist's signature to make the president take it seriously. That letter helped set in motion the chain of events leading to the Manhattan Project and the atomic bomb. Einstein himself never worked on the bomb, but he understood that his signature had started the process. After the bombings of Hiroshima and Nagasaki, he called that letter the greatest regret of his life. In 1952, Einstein was offered the presidency of Israel after the death of Chaim Weizmann. He politely refused, explaining that he was a scientist accustomed to dealing with objective facts, not governing people. For the last 30 years of his life, Einstein pursued what he considered his greatest task, a unified field theory that would describe all fundamental forces with one equation. Most colleagues considered the effort hopeless. Meanwhile, physics moved toward quantum mechanics, which Einstein never fully accepted. His famous debate with Niels Bohr lasted decades. Quantum mechanics suggested that reality at the smallest scales is governed by probabilities rather than strict determinism. Einstein could not accept this. He wrote, "God does not play dice." Ironically, Einstein himself had helped create the foundations of quantum theory through his work on the photoelectric effect, yet spent the rest of his life resisting its implications. There is also a persistent legend that before his death, Einstein burned some of his papers because he believed the discoveries within them could harm humanity. No one knows whether this is true, but the legend itself says something about how people saw him. A scientist who understood the danger of knowledge better than anyone else. On the night of April 18, 1955, at Princeton Hospital, a nurse noticed Einstein breathing heavily in his sleep. She turned to call a doctor but heard him say several words in German. The nurse did not understand German. By the time she reached the bed, Einstein was dead. His final thoughts vanished with him. He was 76 years old. Even on his last day, he asked for his glasses and papers containing calculations for unified field theory. When doctors proposed surgery, he calmly refused. "I want to go when I want," he reportedly said. "It is tasteless to prolong life artificially. I have done my share. It is time to go. I will do it elegantly." His body was cremated and his ashes scattered secretly according to his wishes. But his brain was not. Pathologist Thomas Harvey removed it during the autopsy without proper family consent. He divided the brain into 240 sections and spent decades sending samples to laboratories around the world, searching for the anatomical secret of genius. Researchers later found that areas related to mathematical and spatial reasoning were unusually developed, while regions associated with speech were smaller than average. This may explain both Einstein's delayed speech and his extraordinary visual thinking, yet one question remains. Was he born that way, or did his brain become that way because he spent a lifetime thinking unlike anyone else? Einstein's legacy is impossible to measure because it has dissolved into the fabric of modern life itself. Every time you use GPS navigation on your phone, satellites must account for relativistic effects predicted by Einstein. Without those corrections, navigation errors would accumulate by kilometers every day. Nuclear energy, lasers, solar panels, semiconductors, all emerged from ideas born in the mind of a man who once could not find work as a school teacher. His formula linking mass and energy explained not only why stars shine, but also that every gram of matter contains enough energy to destroy a city. Einstein gave humanity the key to the deepest secrets of matter, and then spent the rest of his life fearing what humanity might do with that key. His correspondence with Charlie Chaplin reveals much about him. Einstein wrote to Chaplin, "Your film is understood by everyone in the world, and you will surely become a great man." Chaplin replied, "I admire you even more because nobody in the world understands your theory of relativity, yet you still became a great man." Two geniuses, one speaking the language of laughter, the other the language of equations, both understood that true greatness needs no translation. Today, physicists still follow the path Einstein opened. Gravitational waves predicted by his theory were finally detected in 2016, 61 years after his death. Black holes predicted mathematically by his equations were photographed for the first time in 2019, exactly as theory suggested. Every new discovery in astrophysics keeps bringing scientists back to formulas written a century ago by a man once dismissed as eccentric. When we look at Einstein's photograph today, we see a messy-haired old man with kind eyes who appears harmless and slightly strange. But this man single-handedly rewrote humanity's understanding of the cosmos, helped usher in the nuclear age, and laid the foundation for technologies without modern civilization could not function. He was a pacifist who unintentionally armed the world, a loner followed by crowds, and a father unable to save his own children. His whole life was a thought experiment. Except the stakes turned out to be real, and we are still living inside the results. Einstein once said that the search for truth is more precious than possessing it. Perhaps that is his greatest lesson, not the formulas or theories, but the courage to ask questions no one else dares ask. even if it means isolation, misunderstanding, and loneliness. His final words dissolved into the silence of a Princeton hospital room, spoken in a language the only witness could not understand. Perhaps he finally found the equation he had searched for during 30 years and took it with him, deciding the world was not yet ready.